So now we're going to do a little bit longer problem for your Millikan example. I'm going to use the iPad. I'm going to go back to the main menu. I'm going to squirt out some new oil drops. You can see that we're looking for one that's suspended. Notice the voltage is 18.2 volts. We're going to hit the little telescope. All right, so this is going to help me measure the radius. So I'm going to look at this right here. It's 540. Let me jot this down. 540, and this is in nanometers. You can see that right here. It also tells me that the voltage is 18.2 volts and the distance between the plates is 3 millimeters. And the density of the oil is 900 kilograms per meters cubed. With that, we're going to do a calculation of how many charges are on this drop. All right, so get your calculator handy. All right, so first of all, we have electric plates. They have 18.2 volts and the distance is 0.003 meters. I've already converted it. So let's figure out the electric field, V over D. All right, so 18.2 divided by 0.003, we have 6066 we'll do 67 newtons per coulomb. The goal here is to get EQ equals mg to solve this. We just figured out E, we're looking for Q, gravity is 9.8, so now we have to do the mass. All right, the mass is based on density, okay? Density equals mass over volume, and it's a sphere, so the density will equal mass over 4/3 pi r cubed. And in this case, we're gonna have 900 equals m over 4/3 pi, and our radius was 540 nano, so 10 to the negative 9th cubed. And then we can substitute that in here. So let's see what we can do. So clear. All right, so I have 540 second EE negative 9, cubing it, timesing it by pi, timesing it by 4. I know this is fast, slow, divided by 3. Okay, that is my mass. Excuse me, that is my volume. Now I'm going to cross multiply it by 900, and I get that the mass is 5.933. I'm just going to get a couple extra times 10 to the negative 16th kilograms. All right, so now I'm going to come over here and work out. Okay, so E was 6066.67 Q. 5.933 times 10 to the negative 16th, and then 9.8. All right, so I've just left that answer in my calculator, so I'm going to times it by 9.8, and I'm going to divide by this 6066.67, and I get a Q 9.58 times 10 to the negative 19th. That's not what the question, that's the charge, but I want to know how many electrons is. Okay, so that's coulombs. So in order to figure that out, I'm going to have to divide by the charge on the electron. So divided by 1.6 second EE negative 19. And again, you're going to find these have to be in a whole number. So 5.99 means we have 6. 6 electrons were on that oil drop. All right, so quick review of how you do this. First, you're going to use the information to find the electric field strength. You're going to use the density formula, knowing that this is a sphere, to find the mass, and then you're going to use the Millikan equation to put that all in. And this is the charge, but this is how many excess electrons, the 6. All right, there's one of your long problems. There you go.